Greetings, all you curious minds out there. Welcome to Brain Food, where we nourish your knowledge. Today, we're diving headfirst into the vastness of the cosmos, as we take a closer look at the largest stars in the universe and how they stack up against our very own sun. From red giants to supergiants and even hypergiants, we'll journey through the celestial giants that dwarf our humble solar orb. So buckle up as we embark on this cosmic journey. To start our journey, we'll first take a look at our very own star, the Sun. With a diameter of approximately 865,000 miles, the Sun is a celestial giant in its own right. Its mass, a whopping 2 nonillion kilograms, that's a 2 followed by 30 zeros, if you're wondering, makes up about 99.86% of the total mass of our solar system. But the Sun isn't just an astronomical heavyweight, it's also the life-giving powerhouse of our planet. It provides the energy that drives our climate and weather and fuels photosynthesis, the process that allows plants to grow and produce oxygen. Without the Sun, there would be no life on Earth. The Sun is also a perfect reference point for our journey. It's the star we're most familiar with, and it's a good medium-sized star. Some stars are smaller, but many others, as we'll soon discover, are much, much larger. So when we talk about the size of other stars, we'll be using the Sun as our yardstick. How many times larger or smaller is a particular star compared to our Sun? That's the question we'll be answering as we venture further into the cosmos. Now that we've established our baseline, let's venture out into the cosmos. Believe it or not, our Sun is a dwarf compared to some stars out there. Yes, you heard right. While our Sun is undeniably impressive, reigning over our solar system with its fiery splendor, it's actually quite modest when compared to the celestial giants lurking in the vast expanse of the universe. Let's start with stars that are just a few times larger than the Sun. Sirius, the brightest star in our night sky, is about twice the size of our Sun. Not a lot bigger, you might think, but if the Sun were a football, Sirius would be a large beach ball. But that's just the beginning. Let's venture further. We encounter stars like Pollux, a star that is 8 times larger than the Sun. Now, if the Sun was still a football, Pollux would be a small car. Quite a leap, isn't it? As we journey deeper into the cosmos, we encounter stars that dwarf our Sun to an almost unimaginable extent. Take Betelgeuse, for instance, a red supergiant in the constellation Orion. It's a staggering 700 times larger than our Sun. If the Sun were a football, Betelgeuse would be the height of the Empire State Building. And yet, even Betelgeuse isn't the largest of them all. There are stars out there that make it seem small in comparison, but we'll get to those later. The universe is a place of mind-boggling extremes. It's a stage where celestial bodies play out an epic drama of birth, life, and death on a scale that's hard to comprehend. Our Sun, for all its life-giving brilliance, is but a small actor in this grand cosmic play. We've only scratched the surface of the awe-inspiring scale of the universe. There's so much more to explore, so many more stars that are larger, brighter, and more extraordinary than our Sun. As we can see, the universe is home to some truly giant stars. Now let's take a closer look at some of the biggest stars in the universe. The red giants. Red giants, the senior citizens of the cosmos. They're stars in their twilight years, having exhausted the hydrogen fuel at their cores. They're now burning helium, causing them to expand and glow with a distinctive red hue. These celestial behemoths are not merely an impressive sight, but they are also key players in the cosmic game. To truly grasp the magnitude of a red giant, let's draw a comparison with our very own Sun. Picture our Sun, a gigantic ball of fiery plasma with a diameter of about 865,000 miles. Now imagine a star that could swallow it up. Not once, not twice, but hundreds or even thousands of times over. That's the scale we're talking about when we speak of red giants. One of the most notable red giants is Betelgeuse, a star in the Orion constellation. If Betelgeuse were to replace our Sun, its surface would extend past the Jupiter's orbit. Mind-boggling, isn't it? But why are red giants so important? Well, they are the universe's alchemists. Inside their fiery cores, they fuse lighter elements into heavier ones, creating almost all elements heavier than helium. Think of the iron in your blood, the calcium in your bones, or the gold in your favorite jewelry. All these elements were cooked up in the heart of a red giant. These stars are not just noteworthy for their size, but for their role as cosmic forges. When red giants reach the end of their lives, they don't go quietly. They explode in a brilliant supernova, scattering their enriched guts across the cosmos. These remnants then serve as the building blocks for new stars and planets. So the next time you look up at the night sky, remember the red giants. These stars are not just gigantic in size, but play a pivotal role in shaping the universe as we know it. Red giants truly put our sun size into perspective, don't they? If you thought red giants were impressive, wait until you hear about supergiant stars. Now, these celestial behemoths are not just your regular stars. They're in a league of their own, representing the true extremes of stellar evolution. Supergiant stars are among the most massive and luminous stars in the universe. They are so enormous that if placed at the center of our solar system, they'd engulf the inner planets and even stretch out to the outer ones. Let's put this into perspective. Our sun, the star we're all familiar with, is about 1 million miles in diameter. A typical supergiant star, on the other hand, is up to a whopping 1,000 times larger. Imagine a beach ball and a grain of sand. That's the kind of size difference we're talking about here. But supergiant stars aren't just about size. They're also incredibly bright, shining tens of thousands to hundreds of thousands of times brighter than our sun. Their intense brightness is due to their high surface temperature, which can reach up to 7,000 degrees Celsius. That's hotter than the surface of most stars. Supergiant stars play a crucial role in the cosmos. They are the primary source of heavy elements in the universe. In their cores, they forge elements heavier than helium through a process called nuclear fusion, then scatter them across the cosmos when they explode as supernovae. These elements, including the carbon in our bodies and the oxygen we breathe, are the building blocks of life as we know it. However, the life of a supergiant star is a fleeting one. Despite their imposing size and luminosity, they burn through their fuel at an astonishing rate and live for only a few million years. Then, in a spectacular display of cosmic fireworks, they end their lives as supernovae, outshining entire galaxies for brief moments. Supergiant stars make our sun look like a mere speck of dust. These celestial titans remind us just how vast and incredible our universe truly is. Now we're entering the realm of the largest known stars, the hypergiants. We've journeyed from our sun to red giants and then supergiants. But now, we're stepping into a realm of cosmic proportions that dwarfs everything we've seen so far. Hypergiant stars. These celestial giants are so enormous that they defy comprehension. To give you a sense of their size, let's return to our comparison with the sun. Remember our sun, that massive ball of fiery gas warming our little blue planet? Well, in comparison, it's but a mere speck. If the sun were the size of a football, a hypergiant would be the size of a football stadium. Yes, you heard that right. A football stadium. But size isn't the only thing that sets hypergiants apart. These stars are also incredibly bright, outshining the sun by millions of times. Imagine the sun, but 1,000,000 times brighter. That's a hypergiant for you. And yet, despite their size and brightness, hypergiants are incredibly rare. There are only a few dozen known hypergiants in our galaxy, the Milky Way. This rarity adds to their mystique and allure. Hypergiants are also significant for another reason. They are the forges where heavy elements like iron, nickel, and even gold are created. When a hypergiant explodes in a supernova, these elements are scattered across the cosmos, eventually forming new stars, planets, and even life. In a very real sense, we are all made of star stuff, and the stuff of hypergiants is the most exotic of all. So the next time you look up at the night sky, spare a thought for these cosmic behemoths. They may be rare and distant, but they're a vital part of the cosmic tapestry. They remind us of the grandeur of the universe and our place within it. Hypergiants are the true behemoths of the cosmos. These stars, with their immense size, dazzling brightness, and elemental alchemy, truly deserve our awe and respect. Now, brace yourselves as we introduce the current record holder for the largest known star, UY Scuti. UY Scuti, ladies and gentlemen, is not just another star. It's a red supergiant star located in the constellation Scutum, and it's a behemoth, an absolute colossus. It's so big, in fact, that if placed in our solar system, it would extend beyond the orbit of Jupiter. Just imagine that. You see, UY Scuti is about 1.5 billion kilometers in diameter. That's about 1,400 times the size of our sun. If you were to fly a plane around it at a speed of 900 kilometers per hour, it would take you over 1,100 years to complete just one trip. Now that's a journey you'd want to pack a hefty lunch for. But UY Scuti isn't just about size, it's also about brightness. This star shines with a luminosity approximately 340,000 times that of the Sun. To put it in perspective, if the Sun were a single 1-watt light bulb, UY Scuti would be a blinding 340,000-watt floodlight. However, don't get too attached. UY Scuti's enormous size suggests it's nearing the end of its life. In a few 100,000 years, it will likely go supernova, exploding and throwing off its outer layers before collapsing into a neutron star or black hole. A dramatic end for such a gargantuan star, wouldn't you agree? But while it's here, UY Scuti serves as a humbling reminder of the vastness of the universe and the sheer variety of the celestial objects within it. It helps us appreciate just how small we are in the grand cosmic scheme. UY Scuti truly makes our Sun seem insignificant, doesn't it? But remember, without our comparatively tiny Sun, life as we know it wouldn't exist. So let's not judge a star by its size, shall we? After all, in this infinite universe, there's room for all. From the smallest dwarf star to the largest supergiant. Well, we've reached the end of our cosmic journey, and what a journey it's been. We've explored the vast reaches of our universe, from our humble reference star, the Sun, to the colossally enormous stars that dwarf it in comparison. We've journeyed from stars larger than our Sun to the awe-inspiring red giants, and then onto the majestic supergiant stars. And finally, we've reached the pinnacle of our stellar journey, the breathtaking hypergiant stars, culminating with the largest star ever recorded, UY Scuti. Each new discovery, each new star we've encountered along the way, has only served to highlight the sheer scale of our universe. It has also underlined the relative smallness of our own Sun. It's a humbling reminder that our Sun, as warm and as bright as it is but a tiny speck in the celestial tapestry. It's been dwarfed time and again by the giants we've encountered on our journey, from the red giants to UY Scuti. But remember, size isn't everything. Our Sun, for all its relative smallness, is vital to our existence. It nourishes and sustains life on our planet. It's the perfect reminder that sometimes the smallest stars can have the biggest impact. I trust this journey has been as enlightening for you as it has been for me. It's been a pleasure guiding you through the universe's largest stars. I hope you've enjoyed the journey as much as I have, and that you've learned something new about our extraordinary universe. As we wrap up, I'd like to express my gratitude. Thank you for taking the time to journey with us. Your curiosity and thirst for knowledge is what drives us to keep exploring, to keep feeding your brain with brain food. Thank you for joining us on this journey, and remember to like, subscribe, and check out our other videos. Until next time, keep feeding your brain with brain food.